Welcome to our video lesson for section 1.5, combination of functions. We're going to look at an algebraic approach for combining functions and see what the result is. Let's get started. All right, there are four basic functions that we can do. We're going to be looking at adding functions, we're going to subtract them, we're going to multiply, and we're going to divide. And each one has its own specific notation. So if we wanted to add things, if we want to find the sum of our functions, then we have f plus g. Those are two functions. And then we see what our variable is here, x, or we could see f of x plus g of x. Both of those are going to ask us to find the sum of two functions. We also could see f minus g of x, which is the same as f of x minus g of x. And then we have the product, or multiplying. We have f times g of x, which is the same as f of x times g of x. And finally, the quotient, we have f over g, or f of x divided by g of x. For this one, though, we have to make sure that our bottom function is not equal to 0. All right, let's go ahead and practice some of this. All right, for our example here, we are asked to find the sum of our following functions. The first function is f of x, which is 3x minus 5. Our second function is g of x, which is x squared plus 3. So we're going to find the sum first. Once we have found the sum, we're going to evaluate our sum by plugging in of x value of 4. All right, we see we have a first step here. I know we're doing the sum, so I have f of x plus g of x, and I've written down my two functions. So we have f of x plus g of x. From here, we're going to go ahead and combine like terms. So I notice that I have two positive 3x values. If I combine them, I get 6x. And then we have minus 5 plus x squared. All right, I'm going to rearrange this just so things are in descending order. All right, so we've gone ahead and we have found the sum. Now we're going to go ahead and evaluate this for when x is equal to 4. All right, so I have 4 squared plus 6 times 4 minus 5, which is 16 plus 24, which is 40 minus 5, gives me a final answer of 35. So I have two answers here. I have my sum of my two functions, and then I have my value when I evaluate the function for 4. All right, for our next example here, we're going to be finding the difference, which means we're going to be subtracting. We have two separate functions again. Our first function, f of x, is 4x squared minus 3x plus 5. And then our second function is x cubed minus 3x. And then when we're done simplifying this, we're going to go ahead and evaluate our new function for when x is equal to 3. All right, again, you can see this is our first step. So we're going to find the difference, which means I'm subtracting my two functions. So I have my f function and then subtracting my g function. All right, we're going to go ahead and combine like terms here by subtracting. I don't have any other x squared, so I just have my 4x squared here. And then I have a negative 3x minus a negative 3x, which becomes plus, so that's going to be 0x. I have plus 5, and then last but not least, minus x cubed. All right, I'm going to go ahead and rewrite this again in descending order. So we have negative x cubed plus 4x squared plus 5. One thing I would like to point out here is that our negative x is actually going to look like this. So we have an x inside of parentheses. And this means we're going to go ahead and cube our x and then make a negative. Okay, let's go ahead and evaluate this for x equals 3 then. So we have negative 3 cubed plus 4 times 3 squared plus 5. And when we simplify all that, we get a final answer of 14. So for our two answers here, our difference equation was negative x cubed plus 4x squared plus 5. And then we evaluate that for x equaling 3. And we got an answer of 14. All right, guys, question time. I want to see how well you can multiply. So we want to find the product for our two functions. Our two functions are 4x minus x squared, and then x squared minus 6. And you can see I've listed our first step here, which is listing them next to each other to find the product. I want you guys to find the product, and then I want you to evaluate that product when x is equal to negative 2, and then select the correct answer. Go ahead and do that. All right, let's see how we did here. So when we go ahead and multiply those together and simplify everything, we should get negative x to the fourth plus 4x cubed plus 6x squared minus 24x. One thing I want to point out here is the expression is negative, not our x value. So we're going to have some parentheses here, even though it's not explicitly written. And now we want to go ahead and evaluate that when x is equal to negative 2. So we have negative 2 to the fourth power plus 4 times negative 2 to the third plus 6 times negative 2 squared minus 24 times negative 2. And for our final answer, we end up getting a value of 24. Hopefully you guys got all that. All right, for our next example, we're going to be finding the quotient, and we're going to find the quotient for our two functions. So we're going to find the quotient for f of x and for g of x, and then we're going to evaluate that when x is equal to negative 3. All right, so quotient is just a fancy word to say that we want a fraction. We want to divide these things. I'm going to put f over x, which means I have x minus 3x cubed minus 2 over x squared minus 3x plus 1. Now, normally when we have something like this, you'd want to try and factor it and see if you can cross-cancel any common factors to kind of simplify our expression here. I'm going to go ahead and let you know that we can't for this one, so this is our final answer. But we do want to evaluate this when x is equal to negative 3. And after we plug in negative 3, we get a final answer of negative 32 over 19. All right, guys, time to test yourself. So for the following two functions, f of x and g of x, we're going to find the sum. We're going to find the difference, the product, and the quotient. I want you guys to see if you can get all four of those. So go ahead and pause the video and see if you can get the correct answers. All right, let's look at our answers. So for the sum, we end up getting a function of x squared minus 2x minus 3. For our difference, we get x squared minus 6x plus 3. When we multiply them together, you get 2x cubed minus 11x squared plus 12x. And when you divide them, we get x squared minus 4x over 2x minus 3. So now when we go ahead and reevaluate them all when x is equal to 4, we end up getting for our answers 5, negative 5, 0, and 0. Hopefully you guys got all of that. All right, for our next operation, we have the composition of two functions, and we see our notation here. And there's two different ways we would see it. The first one is read f of g of x, and then the second one again is f of g of x. And what this really means is we're going to be taking one entire function and plugging it into the other function for every x value. And the function that's on the inside is the one that gets replaced into the outside function. So for our first notation, I'm going to take all of g and plug it into f everywhere I see an x value. And then the second one again, since g is my inside function, I'm going to take this whole function and plug it into f everywhere I see an x. Let's go ahead and take a look at what this actually looks like. Okay, so I have my two functions. I have f of x, which is x squared plus x, and I have g of x, which is x plus 3. And again, we see I have a composition here. So I have f of g of x. I'm going to be taking all of g, and I'm going to plug that in to f everywhere I see an x value. So what that means is I'm going to take this entire expression, x plus 3, and I'm going to plug it in for the x and for the x. All right, so instead of x squared, I'm going to have x plus 3 squared, and then instead of x, I'm going to have x plus 3. I'm going to go ahead and square this. I get x squared plus 6x plus 9, and then I have plus the x plus 3. And when I simplify all of this, we get x squared plus 7x plus 12. And that is our composition for the two functions. Just want to reiterate, I took all of the inside function and I plugged it in to the outside function everywhere we saw an x. All right, so here we have another example of composition of two functions. We're going to be doing this two different ways. The first time we're going to do f of g, and the second time we're going to do g of f, just to kind of compare the process and show it might not always be the same. For my first one, g is my inside function, so I'm going to be taking all of g and plug it in to my x value. So instead of x, I'm going to have 4 minus x squared, and then plus 2. When I simplify all of this, we end up getting negative x squared plus 6. All right, now for the second process, you can see that it's now g of f. F is my inside function, so I'm going to be taking all of my f function, and I'm going to be plugging that in everywhere I see an x, which means I have 4 minus, instead of x squared, x plus 2 squared. All right, when I square that, we get x squared plus 4x plus 4. And now when I simplify everything, I end up getting x squared plus 4x. And then my 4's will cancel out. So if we compare the two, we can see they're not the same. We had x squared plus 4x, and then we had negative x squared plus 6. So it definitely matters the order of our composition and which one is our inside function. All right, for example here, we're trying to identify composite functions. And what that means is we're trying to find two separate functions, an f function and a g function, so that when I take the composition of them, I end up getting my h function. All right, so what that really means is this is my answer. This is what I want my two functions to come together to be. In order to form this function, what we want to identify first is what I call the shell function. And the shell function is what the most dominant feature of our expression is. And in this case, we have two kind of dominant things. We have a fraction, and then we also have something that is squared. So I'm going to take those two things into consideration when I consider my shell function, and I'm going to create my f function to be 1 over x squared. So now what I'm looking for in my g function is what can I plug in specifically into this bottom portion instead of x squared so that I get exactly x minus 7 squared. And notice it's just what's inside our parentheses. So if our shell function is made correctly, then what we have inside our parentheses is going to end up being our g function. And we see that g now is going to be x minus 7. And if I were to then take my composition, if I took my x minus 7 and I plugged it into my x squared, then I would get exactly my h function, which means I know I'm correct. All right, here's another example where we're trying to identify two functions. So that way when we take the composite of them, we get our h. We want to, again, identify what our shell is going to be, what the outside needs to be, and then what the g function is, which is the inside. For the outside, again, what is the most dominant feature of our expression? And in this case, I would definitely say that it has to be our square root. So for my shell, I'm going to say that f of x is the square root of x. Now, again, I have to identify what do I plug into my x to get my x squared plus 3. And since we set it up in this form, I can say that g of x has to be exactly that. It has to be x squared plus 3. That way, if I take my g expression and I plug it into my f, I do get my h, which is the square root of x squared plus 3. So it's kind of a nice way to be able to check our answers. All right, one more example before I let you try one on your own. So here we have again our h function, which is 2x minus 5 squared. We're trying to figure out what we can use as our shell, and then what we can use to plug into that shell to create our h function. So again, we're trying to figure out the more dominant feature of this expression, and in this case, I would definitely say that it has to be the square. So if I want to identify my shell function, I'm going to say that x squared is my shell. From there, I want to figure out what do I have to plug into my shell. So what do I plug into my x squared to get 2x minus 5 squared? And I just have to make sure what is inside parentheses is what I choose. So my g function is going to be exactly that, 2x minus 5. All right, guys, your turn here. So you want to find two functions, f and g, such that f of g of x is going to be h of x, and our h of x is the square root of 9 minus x plus 1. Something kind of important to note here is we have inside the radical 9 minus x, outside the radical the plus 1. So take that into consideration when you're trying to formulate your shell function and then your g function, which is the inside. All right, go ahead and pause the video and see if you can come up with the answer. All right, so this one is a little bit more challenging. We have a couple things to think about. We do have that radical sign, and then we have the plus 1. So for our shell function, f of x, I'm going to say that it is the square root of x plus 1. Setting it up like this means when I'm trying to think about my g function, I just need to worry about the inside. So for my g function, for g of x, it's going to be my 9 minus x. And so now if I were to plug in my g of x into the x value for my f of x, I would get my h function. All right, guys, that's going to do it for our notes for this lesson. Go ahead and start working on the homework. Good luck.